Let's take today's topic, factors affecting transpiration. We'll discuss one by one all factors and how they are affecting rate of transpiration. We have two kinds of factors which are affecting rate of transpiration. One by one we'll discuss on the detailing of. Two kinds of factors are there. Firstly, they are classified external and the next one is internal. So we have two kinds of factors, external factor and internal factor. One by one we will have the detailing of the external factors and it is followed by internal. So try to understand, when we have external, there is first factor which is known as temperature. How temperature is affecting rate of transpiration? We'll take. As we know that as long as temperature is increasing, we have the heating of the leaves also. Leaves, they absorb temperature, and then we have release of water vapor to maintain the internal temperature. So when we have a high temperature, we'll have high rate of transpiration. That is we call directly proportional. So we have that mathematical expression, temperature is directly proportional to transpiration. Transpiration is directly proportional to temperature. It means whenever we have increase in temperature, we will have increase in transpiration, and whenever we have decrease in temperature, we have a decrease in transpiration. So that is the simple understanding. The next factor is light. What is the effect of light? We have a structure in case of the leaves. Last time we discussed, that is known as stomata, and stomata, it is having a structure which is known as stoma. Whenever we have a opening of stomata, we have a starting of transpiration, and the opening is controlled by light. It means in the presence of the light we have the opening of the stomata, and in the absence of the light we have the closing of stomata. That's the reason behind. At the daytime stomata is opened and at night stomata is closed. So that is the concept. So it means in the presence of the light, stomata opens, and whenever we have opening of the stomata, we will have transpiration. Means in the presence of the light, the rate of transpiration increases, and in the absence of the light, the rate of transpiration decreases. I gave you the reason for that one. What is the reason? The reason is opening and closing of stomata. So that is the simple concept. The next one is atmospheric humidity. Atmospheric humidity. And when we discuss about this one, atmospheric humidity, there is that water vapor present outside, and these water vapor are that situated on the surface of the leaf. So whenever we have high atmospheric humidity, we have that high water vapor, high amount of water vapor which are situated on the surface of the leaf, and in this way they are covering the surface of the leaf, that water vapor. So we will have low rate of transpiration. So we have inverse relation. High atmospheric humidity will lead to low rate of transpiration. So whenever we have atmospheric humidity high, low rate of transpiration. So what we have, atmospheric humidity, we are writing AH, and we have that one T, transpiration. So what is relation? Inverse relation we are getting. So how we can write that 1 upon transpiration? It means whenever we have high rate of atmospheric humidity, we will have low rate of transpiration. That is inverse relation. And this you can understand with the help of the observation. Whenever we have humidity, we have a more sweating and it is not evaporating. That we call sweltering weather, where we have that too much sweat but it is not evaporated, and this is called high atmospheric humidity. So that is also the one of the causes. So I hope you have understood. High atmospheric humidity, low rate of transpiration, it means inverse relation. And low atmospheric humidity, high rate of transpiration. Easy to understand. The next one is wind. We are discussing about the external. After that we'll take internal. So whenever we observe about wind, when wind is blowing, we observe there is that decrease in temperature. We have a decrease in temperature. And when wind is blowing in the fast rate, at the time of the storm, we have that in closing of stomata. So when wind starts blowing, initially rate of transpiration increases due to opening of the stomata, but in case of the storm, we have a closing of stomata to avoid the rate of transpiration. Wind is also responsible to decrease temperature, and that will cause the decrease of the rate of transpiration. So we have the various understanding regarding winds. So in moderate condition, we have also that one, low rate of transpiration. Storm, closing of stomata, we have stopping of the transpiration, low rate of transpiration. And when wind starts blowing, we have increase in transpiration due to the opening of the stomata. So that is the wind. And then we have atmospheric pressure. The last one is atmospheric pressure. There are various plants who are having their life in high altitudes, like pines, we have a cycas, cedrus, we call conifers. There is a plants who are known as conifers. Conifers are those plants who are having a production of cone. Cone is a reproductive structure. So we have name after cone, conifers. Conifers, they are growing in high altitude area. When you visit any hill station, when you go to Nainital, Shimla, there are conifers are present. That Pinus, Cycas, Cedrus, Ephedra, these are some conifers. So what we have, that there is a low atmospheric pressure, and due to this low atmospheric pressure, loss of water will increase. That is the concept. Whenever we have that fluctuation in pressure, will have the change in rate of transpiration. So when plants, when they are growing in high altitudes, they are facing low atmospheric pressure, and in low atmospheric pressure the rate of transpiration increases. That is the concept. same case in case of our case, you can observe when we go to altitude, we have a various kinds of changes, and that we have change in breathing, that is we call altitude sickness. To get the adaptation that according to the surrounding, that is acclimatization we call, and it is due to low atmospheric pressure. So plants are also having their adaptation. Whenever we have a low atmospheric pressure, conifers, they lose water in the form of water vapor to compensate pressure, and that is the effect of atmospheric pressure. It means at high altitude there is a low pressure, and then we will have increase of the transpiration. So what we have, atmospheric pressure is low, transpiration increases, that AP we call. Atmospheric pressure is low, transpiration is increases. So that is the concept. So these are external factors. I gave you all: temperature, light, atmospheric humidity, wind, and atmospheric pressure. Now let's take internal factors. Internal factor we will have here. Try to focus here. Internal factors, this one. So we have various kinds of leaves. We have first structure of leaf. Structure of leaf. So when we understand plants who are growing in xerophytic condition I taught you. Whenever we have that one in scarcity of water, plants are growing in scarcity of water, that condition is known as xerophytic condition. And in the scarcity of water, what they need to do, they have to save their water, whatever they are getting from the soil. So for that reason they are changing their structure, and in which they are changing the structure of leaf, because that above 90% water is lost through leaf. So leaves are having small, converting into small, sometimes leaves are converting into spines, and leaves are having a thick covering of cuticle, and this thick covering of the cuticle is inhibiting the process of transpiration, and this thick covering of cuticle is responsible to sunken stomata. So we have the various changes in case of the leaf. We will take one by one. That is small leaf. Small leaf, we are talking about xerophyte. Xerophytes. Plants are growing in scarcity of water. So small leaf they have, and leaves are sometimes converted into spine, and that covering of cuticle, and we have sunken stomata. These are the some adaptation in case of the xerophytes. So these all are having one function, to reduce the rate of transpiration. It means whenever we have a change in the structure of leaves, we will have change in the rate of transpiration. So in that context, we have hydrophytes, mesophytes, and xerophytes. They are having a different rate of transpiration because they have a different kinds of availability of water. Sometimes that in xerophytes water is very less, so availability is less, availability is not there, and when availability is not there, they have to save water. When we talk about hydrophytes, they are growing into water, there is nothing to worry about water. So plants are growing, they are focusing on their other activities, and they are not saving their water. So that in case of the mesophytes we have a moderate condition, so they have some adaptation so that water is not lost at a certain extent. So these are the some understanding. So it means structure of leaves are also important in case of the transpiration. The next one is root shoot ratio. Next one we call root shoot ratio. Root shoot ratio. So as we know that the amount of the absorption is dependent upon root, and the amount of the transpiration is dependent upon the shoot. So whenever we have increase in root shoot ratio, we will have that increase in the absorption. When roots are increasing, we have increase in absorption, and when absorption is increased in that proportion, shoot is also increasing, and then we will have increase in transpiration. So what is the concept? Increase in root shoot ratio, we will have increase in rate of transpiration. So these are the two internal factors. Here we discussed external factors. Here you can add one also, that is availability of water. Availability of water. This one you have to add one more. So when water is available, we have high rate of transpiration, and when water is not available, we have low rate of transpiration. We can understand about in terms of the money. When we have money, we can spend, we can buy things, and when we do not have money, we can't buy. So when we have availability of water, root can absorb, and then we have transpiration. So these are the factors, external or internal, we discussed.